Hello. Hi, everyone.
Hi, ma'am. Good evening.
Hi, hi.
Good evening, ma'am.
Good.
Good
So,
evening, ma'am.
yeah, good evening. So today we will discuss on last session on assertions and coverage. Okay. So till now we have completed all the topics of coverage. So we have discussed on functional coverage, toggle coverage, different transition bins and cross coverage, code coverage, and assertions also, right? How to write the assertions, immediate assertions, concurrent assertions, and different simulator directives, so nothing much system task in assertions, and there are different small topics out there, so we have completed all the assertions. So if you have any doubts, I'm updating the sheet also, recorded session sheet. So go through the recorded session, you can revise in your free time. Okay. And also I have shared some of the assignments in coverage and assertions, right? If possible, tomorrow I will share you another session, another assignment on assertions. Okay. So meanwhile, whatever the assignments I have shared, so please practice on that. Okay. And so today's session we will discuss a simple design program and also UVM code, UVM test bench for design program with the coverage and assertions. Okay. So do you have any doubts till now?
No,
Hello,
ma'am.
ma'am.
Yeah.
Actually, I did not able to find those recorded sessions, ma'am, in the sheet, second and third. You said you have already updated.
Second and third I already updated. Second one updated. Third one is today only, right? I think. Second one I have updated and have mentioned the codes also, immediate assertion and concurrent assertion. These codes. Check once.
Yeah, okay.
Okay. So yeah. So shall we start the today's session? At the end of the session, we will discuss on APB protocol design part. So in APB protocol, we have seen different transfers, right? Burst transfers, and in transfers, we have different transaction IDs. So based on that, how we can design the waveform, design the AHP protocol. We'll look into that after this. Okay. So here is the UVM code for adder. Okay, simple adder. So module created the adder module. What are the inputs? Clock reset or the inputs, and AB or the inputs. Sum is the output. So always at the rate of posage clock, if reset is high, sum will be 0, or else sum is equal to A plus B. It do the addition operation of A and B. So A plus B. So for this, how we can write the UVM code? Uh, Nilesh and Chandana, Gurushant, have you gone through the UVM sessions I have shared you? Do you have idea on UVM?
No, ma'am. We have some basic idea on UVM, but we have to go through those videos.
Okay, okay. So if possible, go through the video. Anyway, I will take you separate sessions for UVM. Okay. So just go through that sessions. If you have any doubts, let me know. Mostly in that sessions, I have covered all the topics. Most of the topics I have covered. So if any doubts you have, so we will discuss. Okay. So first, for this code in UVM, we need to start with the transaction. So here we don't have any transaction class. In UVM, we have the sequence items, and sequencer. So what is the difference between sequencer, and sequence item? What is the difference between sequencer, and sequence item?
First, we create sequence item. Then we will send it to sequence, and then through sequencer we can send the sequence to driver.
Okay, so sequence item is nothing but the transactions here. Okay, sequence items are nothing but the variables we have. So those sequence items, we do the randomization in the sequence. So sequence is nothing but the communication between sequence and the driver will happen through sequencer. Sequencer is just a routing purpose, just a mediator between the sequence and the driver. But in system Verilog, there is a generator block, right? That generator block is replaced with a sequence here. Okay, sequence items are nothing but the transaction class. However, we write in system Verilog, same here, we write the sequence items as a transaction class. Okay, sequencer is just a mediator. It already have the predefined logic, so at our end we don't create any logic for the sequencer. Okay, so already it have its own logic, like a router logic or routing purpose or mediator purpose. Okay, so first sequence items. First we need to look into sequence item. What is the main difference between system verilog transaction class and UVM transaction class? So first of all, sequence item class sequence item extends from UVM sequence item. UVM sequence item is the library. You already know in Verilog, in UVM, everything um, we will get the data from the parent class. So here UVM sequence item is the default class, predefined library. It consists of all predefined data, predefined library. So whatever we are creating newly, everything we will access from that parent class. Okay. So that's why sequence items are extending from the UVM sequence items, like that the sequencers extend from UVM sequencer, which is a parameterized class, and also driver extended from the UVM driver, like that everything we have predefined libraries in the main parent class in the UVM library. Okay, so next here normally in a transaction class in system verilog we don't use like this, any kind of like this. Okay, but here in UVM we will create every field. Why? Because it's a factory registration concept. So can you tell me what is mean by factory registration? What happens if we don't do the registration, and what are the ways we can do the factory registration? Hmm? CB,
In factory
Sanjay.
registration, we just register our object, ma'am. For example, if we use sequence data means it is considered as object. Instead of creating low-level code by using factory registration, we can access the factory, ma'am, so that we can use some inbuilt functions like print, like Facebook.
Okay, so factory registration concepts allows to use hold, do, hook methods. We can use different functions or there we can use those. Okay, so that's why we need to do the registration. Okay, so nothing but creating. Um, so here for object class sequence item is a object here. Okay, so UVM object utils a begin. If there are multiple number of inputs, we use a begin. Actually, sequencer, driver, monitor, scoreboard, all these are components. Okay, so how we will create the components means UVM, macro UVM component utils, but here it is a object. Okay, so that's why we are writing a UVM object util sequence item. Next, A, B, sum, all these are fields. That to which data type? It's an int data type, integer data type. All integer related data types comes under int. Okay, bit byte, like that. So UVM field int A, UVM all on. UVM all means what? We have UVM all off, all on. Priority wise, we have high, low, medium, nothing but verbosity levels. So how you want to print the data at the console? Those are the verbosity levels. Okay. So next, however, we declare in the system verilog, same here also. Inputs must be declared as a rand data type. Output must be declared with its data type. No need to declare as a rand or randc because output doesn't do the randomization. Okay. Next, function new string. We need to create the class. And next, constraints. Constraints are nothing but just to for controllability. You can take according to your scenarios. You can consider the constraint names. Okay, so this is how we can write the sequence item. Clear, everyone?
Yes, ma'am.
Okay. Next, sequence. Sequence means what? In the sequence, we do the randomization from the driver. We connect using the TLM port. Driver will request for the sequences. Sequence will send the number of sequences to the driver. If you go to the TLM port concepts, there you will understand if sequencer work as a initiator and driver works as a target, what ports you need to use. Get port, put port. If initiator is a target, if driver is a initiator, sorry, if sequence is a initiator and driver is a target, then what are the methods we need to use? Put and get methods. So once you have the clarity on TLM ports, then you can understand easily, you can write. Okay, so here class, name of the class is add sequence extending from UVM sequence. It is a parameterized class. Okay, so that's why we need to pass the parameters. So here we are passing sequence item as a parameter. We need to pass the sequence items as a parameter. And next, sequence is also a object. So that's why we are creating UVM object utils, creating the sequence and declare p sequencer. We have a p sequencer, m sequencers in UVM. What is the difference between p sequencer and m sequencer? What is the difference between p sequencer and m sequencer?
I don't know, madam. Please explain.
Who is that?
Yeah, Sanjay, ma'am.
Okay, others? CB? Surya? No
I
idea?
think the sequencer,
Mm.
that is M sequencer used in virtual sequence, ma'am. Virtual sequence.
Okay.
It's
So,
inbuilt handle.
okay. So actually P sequencer and M sequencer are two different handles used to access the sequencer in the specific context. Okay, that means just M sequencer means these handles are available in the UVM sequences and it pointing out to the sequencer on which the sequence is running. So it is used to sequence the interact with the sequencer. It should be started the sequencer with the driver. Okay, because sequencer is a mediator, right? And mainly like a practical example in the sense, suppose example, if you are using customized sequencer, example derived from the UVM sequencer. Okay, you need to cast M sequencer to the specific sequencer that is accessing it specific fields or methods, whatever the methods and fields are there. So M sequencer is a base class handle of UVM sequencer base, whereas a P sequencer is explicitly defining the UVM declare P sequencer. There we use UVM declare P sequencer. Okay, so mostly UVM sequencer requires the casting. Sorry, M sequencer requires the casting to the specific sequencer type. P sequencer just provide automatically the safety and implicitly available in the sequences for M sequence. Whereas a P sequencer we need to declare externally. Okay, so like this we need to declare externally. UVM declare P sequencer. If you want to use P sequencer, we need to declare externally. But for M sequencer, no need to write like that. UVM M sequencer directly you can write. Okay, and M sequencers are just for generic operations. P sequencers are mostly for accessing the custom sequencer features. Okay, like customized means like what are the particular sequences based on the constraints like that. If you want to use for customized sequences, there you use the P sequencer. Okay, so P sequencer is customizable, not like a M sequencer, and it is used in like defining the fields and the macros methods, different methods. Okay, so that is what the example. So just M sequencer is for generic purpose, P sequencer is for specific fields and methods. Okay, so whenever you are using different sequencer, whenever you are using sequencer, you can use either P sequencer or M sequencer, both are same. And next here function new, creating the constructor, nothing but class. Next virtual body task, 20 times repeating. Request equal to sequence item type ID create. So here we need to create the requests. So request will be sent to the driver. Driver will respond and um, it will request for the next sequence item. Okay, so start sequence start item of request, assert of request dot randomize. Here we are doing assert dot request of randomize and finish item of request. So if you go to driver class, in the driver class these all are same. However, we take the path, right, for virtual sequence path and creating the driver. Driver is a component, so that's why we use UVM component utils. And next virtual interface, creating the class constructor and a build phase. So in UVM we have different phases, right? Build phase, connect phase, end of error operation, start of simulation. Next, what are the next phases? Run phase. After run phase, we have final phase, like that. Okay, so in the build phase, just we will take the whatever the connections are there, just we will initialize the connections. Okay, not connecting, just we write the names. Okay, so configuration. So what is mean by configuration? How we write the config db? So if UVM config db is 0, then this function, this method will be work. Virtual add if get this dot virtual interface dot VIF. So fatal error. If the condition fail, it give the fatal error. Virtual interface must be set to for this name. Build phase. Okay, so for configuration everyone must need to know the syntax is very important. Okay, so what happens if we use get method and put method in place of this? You can also put null, in which case you can put null and which case you can put this.
This represents the current class, ma'am, the driver class.
Okay, if you put null,
There will be no previous classes, ma'am. It is like parent class, ma'am.
okay, So once everyone check with the UVM config syntax, next main task. So in the run phase, we will write the main task. So what is the task we are writing here? 21st line, sequence item port dot get next item of request. So we are requesting for the next item in the driver and drive method and sequence item port dot item done. Okay, without writing all these steps in the driver and the sequence, we can write only one single statement in place of these four. What is that single statement? Single macro. What is that
What is the
macro?
question?
In place of
Question,
writing
no?
these four, in place of writing these four statements, we can write only one macro statement. What is that? You can also write the constraint using one macro. What is that?
Just run, no?
No?
UVM do it is already present there.
Yes, UVM do macro. Okay, if you use UVM do with, it represent the constraint also. Do with means inline constraint. You can write tick UVM do with. So by default, all these statements execute um, by default. Okay, so UVM do with means it will create the request item, start item, and it will do the randomization and it complete the finish item. So all these things it will generate automatically. So that is what sequence. And next sequencer I already told, right? Our side we no need to write any logic by default. In the parent class it have its own logic, the mediator logic. So that's why you just need to create the class and just create with a function new constructor. That is enough. And next to driver also same. In driver also we will write a build phase and a run phase, and need to send transaction data to the DUT data. So however we write in system verilog same. And then monitor also same, however we write in system verilog same, but here in monitor we use build phase, connect phase, run phase. Connect phase we will connect in the environment top level, okay, or agent, not in a monitor or driver. Here we just use the connection instantiations and a run phase. Through the run phase only we can send the data from the generator to driver to DUT to monitor. That's why we use the run phase. Okay. And next, in the run phase, we will send DUT data to the transaction data. Okay. So this is how we can write the monitor logic. Next, scoreboard. So scoreboard means how we can write scoreboard also same, but here we use analysis port. What is the difference between TLM port and analysis port?
Analysis port means, for example, we connect many environment into one scoreboard, ma'am. So in that case, we use analysis port instead of normal TLM ports, ma'am.
Okay. So analysis port means one to many. Okay, like if you see in UVM test bench, if you want to connect with the sequence to driver, it is a one-to-one connection. Like that monitor to scoreboard, only one-to-one connection. But in UVM, we will have coverage report, coverage block will be there, checkers will be there. So from monitor to, we will pass the data to the scoreboard, checkers, coverage. So all these different blocks we will send, right? So that's why for transaction connection one to many we use this um, analysis port. Okay, so analysis port is for one to many connections. TLM port is for one to one connection. Okay, next to create the sequence items queue and function constructor and build phase after that write method and in the run phase. In the run phase, we will get the data from the DUT to the in the scoreboard. In the run phase, we will write the checking checker. That means reference model. Okay, so we will take the golden reference values, right, and we will check with the what is the actual value and the expected value. Okay, so here it is a adder. Adder means what is the expected value, what is the um, getting value. Okay, so here how we can check, whenever a plus b value is equal to sum, then we will get the expected value, correct value, test is a pass. If a plus b value is not equal to sum, then we will get the error. Okay, so that is how we need to write the code here. And next, environment. In the environment, we will connect to top level all these four modules. Okay, so before environment, we have the agent. Agent means what? In agent, we will have the generator, driver, monitor. Like that here, sequence item, sequence, sequencer, driver, and monitor. So all these three blocks, three classes, we will connect in the agent. Agent and the scoreboard, we will connect in the environment. Okay, so here all the sub modules are included in the top level in that list, and agent is created. Class agent extend from UVM agent and creating the instances for the sequencer, driver, monitor. In this only we will call all the blocks through the instances, right? So function void build phase. In the build phase, we will connect driver and a sequencer, driver to the sequencer and monitor. So what is the difference between active agent and passive agent?
Active agent means it will both initiate, ma'am. It initiates the transaction, but passive agent, it just receive what the transaction comes. For example, monitor in like that in operations.
Okay.
Active agent contains three components:
Okay.
driver,
What are
sequencer, monitor.
okay?
And passive means only monitor.
Monitor alone.
Monitor. So as he told before, some active agent is also a initiator. Initiator means by using the sequencer and driver, it can generate the transactions also. But in the passive agent, as we are connecting only monitor, it will receive the result only. Okay, it cannot generate any random values. Okay, it cannot initiate the transfer. So here we can create either active agent or passive agent. So here what is the agent we have taken?
Active.
It's an active agent because we have written driver, sequencer and also monitor block. Okay. And next connect phase. In the connect phase, we can connect a driver block dot sequence item port dot connect of sequencer one dot sequence item export. Sequencer and the driver are connected in the agent. That too in the connect phase. Okay. Next, this agent and scoreboard both are run in the environment. Agent, scoreboard, and coverage. Coverage is also extra file which is connected to the monitor. Okay, so that's why agent, scoreboard, coverage, class, UVM extend and environment extending from UVM environment. Agent, scoreboard, and coverage are created. Before that, we will look into the coverage also, what we have written. So what is the size of here adder? 4 bit, 4 down, 3 down to 0. Sum is 4 down to 0. 3 down to 0 means how many combinations?
16 combinations.
16 combinations. So here if you see in the coverage report, created my coverage extending from the UVM subscriber. It's also a parameterized class, so passing the parameter sequence item, and created my component utils, my component, and created the sequence item and cover group. Cover group, my coverage option dot comment is equal to coverage for adder. just it will write as a name, coverage for adder, and first cover point, what we have taken first cover point, it should cover from 0 to 9 and 10 to 15 lower bits and higher bits, MSB and LSB bits. Okay, and next next group lower bits, higher bits for A and B. Okay, so combination cross coverage. If there are two inputs, better we can go with the cross coverage. Why? Because it will check overall every scenario, right? It doesn't miss any scenario. So cross coverage is used here. And function new, just creating the coverage class. Okay, and also creating the right transaction and my coverage dot sample. So coverage, we always use the same method, right? My coverage dot sample. And report phase, in the report phase, we print all the whatever you want to print at the display statement. You can write those variables. Okay, input, output, clock reset, and any control signals. That's enough. Okay, so this is how we can write the coverage. You already know how, what are the different ways we can write the coverage, right? For transition bins or normal coverage report, cross coverage, code coverage. Yeah, please tell.
What is that low I mean? What are that means?
Low high means, see here, A B, right side, if you observe right side second line, A B or 3 down to 0. 3 down to 0 means how many bits? Of 4 bits. 4 bits means how many combinations it will generate? A B
16.
16 combinations, right? So bins, how we can generate the bins? Bins, you can generate any bins. You can generate 2 bins or 4 bins or 8 bins, according to the whatever you want to cover. You can generate n number of bins, right? So here we have created 2 bins. That too, how we have created 2 bins? First, lower order, 0 to 9 in 16, total 16 bits, 16 combinations, divided by 2. 8 one side, remaining one side. So 0 to 9 one side, remaining bins 10 to 15 one side. Like that, if you want to create 4 bins, you can create 4 bins also. 16 by 4. So each bin will check for 4 bits. Like that, if you want to write 8 bins, then 16 by 2. Each bin have 8. Okay, like that. Clear?
Yeah, clear.
Okay. Next, assertion. How we can write the assertion for this? Already we have seen lot of assertion examples, right? So how we can write? See here, property, assert property. Assert property means which type of assertion? Is it immediate assertion or concurrent assertion?
Concurrent assertion.
Concurrent assertion. So first we need to write the property. Inside that we can declare the variables, and at the rate of posage clock, if reset equal to 0, OPA equal to A, OPB equal to B is triggered. So is it overlapping or non-overlapping?
Non-overlap.
Non-overlapping. So sum must be equal to A plus B. So whenever sum is equal to A plus B, it will do the trigger. It's a non-overlapping. That means it, it doesn't check within the clock cycle. Okay, if any overlapping occurs within the same clock cycle, it just avoid. Okay, and check for non-overlapping case only. So that is what the assertion we can write for this simple example. But try for different designs. In system verilog we have worked on a lot of designs, right? I will also share you some design programs for flip-flops or some counters and all. Try to develop from scratch. Okay, and so this is how we can write the assertion. And next, test.sv. Test.sv means here we will create the environment and sequence. So we'll create the function, uh, uh, nothing but constructor, a new constructor. Next, build phase. After build phase, run phase. In the run phase, we will start the sequences. Okay, so phase dot drop objection. In 26th line, there is a phase dot drop objection. What is that mean? Rise dot drop objection and phase dot drop objection. What does it mean?
We generally use it for run phase, ma'am. Phase start right means it starts that run phase and it waits till all the run phases are completed, and then phase start drop means it completes that run phase.
Okay, so phase dot drop objection, rise objection is nothing but just synchronization purpose. Synchronization purpose means, suppose generator side we are sending 10 transaction, and driver side also it should receive 10 number of transaction. Okay, so if it not receive 10 number of transaction, it should wait until both number of transaction at receiving side and transmitting side both are must equal without any data loss or without any delays. Okay, so for that purpose we use phase objection and drop objection. First, phase objection will be high, so phase objection is must be equal to the drop objection. That means both generator and driver completed their own task, and whatever the transfers are initiated from the generator, all transfers are uh, completed in the driver also. Okay, just for to make sure we use the phase objection and the drop objection in the UVM. Okay, so Nilesh and other members from advanced verification group, please go through the UVM sessions as soon as possible. Okay, so that you will get the clarity. If you don't have, if you have doubts, I will take the session. Okay, next, after test dot sv, need to write test bench. You already know what is meant by test bench. Here we will create the DUT and also make the connections. Just UVM config and dump file and interface. You already know the interface, no need to explain. So in interface, we included the assertion.sv file. Okay. So this is how we can write the coverage and assertion in any design. Okay, so whatever the designs you have created before now, before, just create coverage report and assertion also. Okay, so that you will get the practice, and I will share you the UVM code, this code. Everyone check line by line. Okay, so if you have any doubts, please ask. Run. Please create run.do file. For coverage, we need to create the run.do file, right? So you can copy the steps. Create run.do file. Okay. Error EP waveform message could not find. So everyone try to join tomorrow morning session at 10:30. We will discuss the AHB, okay, AHB protocol programming. See here, 2 plus 5, 7, 2 plus 10, 12, 5 plus 4, 9, 5 plus 3, 8, 2 plus 7, 9, 5 plus 0, 5, 2 plus 14, 16, 1 plus 1, 2, 9 plus 1, 10, 6 plus 1, 7, 5 plus 8, 13, 15 plus 5, 20, 11 plus 5, 16, 2 plus 2, 14, 1 plus 2, 3, 13 plus 2, 15, 13 plus 1, 14, 2 plus 1, 3, 12 plus 2, 14, 11 plus 2, 13. Okay, so addition is getting properly. And interface signals, DUT signals, test bench signals, randomized signals. And in the console, all our test passed, so you can observe. Top level, all the blocks, coverage, and test is passed here. Value of sequence item A equal to 0, B equal to 0, sum equal to 0, test is passed. A equal to 2, B equal to 5, sum equal to 7, test is passed. A equal to 2, B equal to 10, sum equal to 12, test pass. B A equal to 5, B equal to 4, sum equal to 9, test pass. And A equal to 5, 3, test pass. Okay, like that. Check the output for each test. And here you need to print the coverage report also. But here coverage report is not generated. Just work on that. I'm opening the okay. So here before run.tcl file is not included. Okay, see coverage report. 66.66% hit and 100% is target, but only hitting 66.6%. So if you want to check what bins are hitted, what bins are not hitted, what we need to write?
Option dot per instance equal to 1.
Option dot per instance equal to 1, so that you will observe which one is properly hitted and not hitted. Low side 66.66, low side 20 number of hits, but high side 0 hits. Here B 12 hits, 8 hits, and here are the outputs 12, 8, covered. Here this one not covered. Just check where it is not covered and how you can cover that case. Okay.
Yes, ma'am.
Next For assertion, we didn't written any display statement. So that's it. This is how you can write the coverage report and assertions for any program or any project. Is it clear, everyone, till here?
Yes, ma'am. Share this code, ma'am, after the session.
I will update now only. So everyone try to work.
Did we, ma'am, did we write test cases for this, ma'am?
Test cases means just in the sequence you will write the test cases. Test cases means what? Here class add sequence is there. In that we have written here sequence item is there. In that we have written one constraint. A is 2, 1, 2, 5. Like that for B also you can write for B whatever the values. Okay. I think here we didn't return the constraint
Yes,
for
ma'am.
B.
Because of this only, it's printing 50%, I think.
So some random values it will generate. So you can write some other test case. Another test case you can create sequence item 1 extending UVM sequence item, and that you can create another constraint like that. Those are nothing but number of test cases. I think in the last FIFA example I have shown you, right? Test 1, test 2, test 3. Not for your batch. Huh? Okay, so I think for you I didn't added a session 2 session. I will add now. FIFO.
Add the test cases code also. You
Okay.
can work on it.
So here in FIFO, in the generator block, see here, 3 transactions created. Transaction TR, TR1, T2. So here in the transaction, constraint 1 in one class. Next class transaction 1 extending from trans second class, and third class, the 2 inheritance classes. So in the first class one constraint, second class another constraint, third class another constraint. Okay, so these are nothing but test cases we call. Okay, test cases means what? Different scenarios. In each test case, some scenarios, some cases we need to cover. Okay, so but this added try to create some test cases also, different scenarios, and observe the coverage. Okay.
Okay.
Any other doubts? Others?
Can we write the test cases in sequence also? Sequence class.
Sequential?
We can write test cases in sequence class also. I'm asking.
In sequence class, we just do the randomization only, right? We won't write this here test cases in the sequence. In the sequence items, you can write. Okay. Or you can write the sequences in the class, in the same class also, sequence also, no problem. Because anyway, we will create the inheritance concept, right? So you can write. That's not a problem. Anywhere you can write. But you need to create that sequence instances and need to create the those test cases like that instances. Okay. Any other doubts? Others? Even coverage analysis, all these things you can write in the anywhere you can write. Okay, others, do you have any doubts? No. I have updated the sheet, so please practice everyone. Okay. And Nilesh, Gurushant and Chandana try to go through the UVM sessions and let me know if you have any doubts. We will discuss in separate sessions for UVM. Okay.
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 Okay, ma'am.
Okay.
Okay, ma'am.
Did you understood today code? UVM code?
No, ma'am, not properly.
Not properly. Okay. Okay, no problem. Take time. No hurry, right? Just take time. You just join, right, for system develop. Okay, others, Surya?
Not completely, ma'am. I'll get back to you. Okay.
Okay, sure. Just go through that and I will update the session by end of the day. Okay. Okay, then thank you all. Bye.
Thank you, ma'am.